now theorem number 10.9, that is most important theorem for the numericals. So now what is the theorem 10.9? Statement is angles in a same segment of a circle are equal. Angles in the same segment of the circle are equal. So what is segment? Segment is the region of, or you can say segment is the portion of circular region of circle enclosed by the arc and chord. Done? So portion of circle enclosed by arc and chord is known as segment. So angles in a same segment are equal, that we have to prove. So let's start with diagram. The proof of this theorem based on the proof of the previous theorem, that is theorem number 10.8. Done? So here one circle with center O is given and the arc, or we can say arc PQ is given. So here this is chord PQ and this major arc PQ and this chord PQ form one segment. Consider these 2 points A and C, so they will form one segment PACQ. Done? So given, so here we are given two angles in a same segment. So segment PACQ is there. So in this segment two angles are given. The two angles are angle PAQ. No, this is angle PAQ and the second angle in the same segment is angle PCQ. So two angles in a same segment are given. The circle with center O is given. So in circle, here we are given that in circle with center O, circle with center O, two angles are given. So angle, which two angles in a same segment? Angle PAQ and angle PCQ are angles in the same segment. Two angles in a same segment are given. So to prove, what we have to prove? If we are given two angles in a same segment, then we have to prove that these two angles are equal. Measure of these two angles are equal. So to prove angle PAQ equal to angle PCQ, this we have to prove. Done? The proof of this theorem based on the theorem 10.8. What we have studied in theorem 10.8. So now proof. According to theorem 10.8, angle subtended by this chord PQ at center, so that angle is angle POQ, angle subtended by the chord at center is double than angle subtended by the same chord at the point on the remaining portion of the circle. So here this angle POQ from theorem 10.8, measure of angle POQ is twice of angle POQ is the angle subtended by this chord at center, that is equal to twice of the angle subtended by the same chord on the remaining portion of this chord. So here angle subtended by this chord PQ at point A is angle PAQ. So this POQ is twice of angle PAQ. Say this one as a result number 1. Similarly, if another point on a chord is point C is, so here again angle POQ is twice of angle PCQ. Say result number 2. Both results are equal to angle POQ, so we can compare these two angles. It's a twice of angle PAQ equal to twice of angle PCQ. So this 2 will be cut and therefore we can say angle PAQ equal to angle PCQ. What is angle PAQ? Angle PAQ is the angle subtended by chord PQ at point A, and PCQ is angle subtended by this chord PQ at angle C. These two angles are the common angles. That means these two angles are the angles which lies in the same segment. These angles lies in a same segment. Another word is angle subtended by the same chord, or you can say as angle subtended by the same arc on a circle. Another name is, we can represent these two angles by three names. First, that is angle subtended in same segment. Angles, meaning of these three statements are same. First, angles in same segment. Angles in same segment. So angles in same segment are equal. Also they are known as angle subtended by common arc. That common arc is arc PQ. Also, instead of arc, you can say it's a chord PQ. So they are nothing but the angle subtended by the common chord PQ. So angle subtended by the common chord on a circle are equal. Angle subtended by the common arc on a circle are equal, or angles lies in a same segment are equal. So this is the proof of theorem 10.9. Done. And one converse of this theorem 10.9 is also there. So we have to study that proof. Converse of theorem 10.9. So angle subtended in semicircle is always 90 degree. The statement of theorem is converse of theorem. That will be also used in our numericals. So the statement is angle subtended in semicircle. Angles subtended in semicircle are always right angles. Angles subtended in semicircle are always right angles. So for the proof of this theorem, we will use theorem 10.8 and specifically the second part of that theorem 10.8. What was the second part of that theorem? Second part is the case number 2, in which our arc PQ is semicircle arc. So this is arc PQ, which is semicircle arc. Done. So angle subtended by this arc at the center is nothing but this straight angle POQ. So POQ is twice of the angle subtended by this arc on the remaining portion of the circle. So we prove that angle POQ is twice of angle PAQ. But here POQ is the straight angle, so measure of this angle is 180 degree, and therefore this one is 180 degree equal to twice of angle PAQ. So therefore we can write angle PAQ equal to 180 by 2, so it's a 90 degree. Done. So what is angle PAQ? Angle PAQ is angle subtended in semicircle. Suppose this PQ arc is semicircle arc, remaining portion is also semicircle. So here angle PAQ is angle subtended in semicircle. So any angle subtended in semicircle is always 90 degree. That is the converse of statement of theorem 10.9. This is another most important statement that we will use in our numerical. So whenever the semicircle is there, and if angle subtended in semicircle is given, so that angle subtended in any semicircle is always 90 degree. So this is 90 degree. This is another angle. This is also 90 degree. Suppose this is chord AB, and this is point P, and this is point Q. So this is nothing but the chord and arc. This is one segment. Angles subtended in the same segment are equal. So these two angles are equal, and both are equal to 90 degree as they are in semicircular region. Clear? So angle subtended in any semicircular region is always 90 degree. Angles subtended in semicircle are always right angles. Angles subtended in same segment are always equal. And if that segment is semicircle, both angles are equal as well as they are 90 degree. Clear, students? Pause the video and note it down.